first question. The gradient to the curve which passes through the point A is 3. Okay, so you are given a curve with the equation y equals to 2x squared minus 5x plus 3. Okay, passes through the point A. So let's say this is point A. Then we have to find the coordinates of this point A. So we have to find the coordinates of this A, x, and y. Okay, so at this point A, we will have a tangent, a line of tangent. Then the gradient of this tangent will be dy dx. Okay, dy dx is the gradient of the tangent at this point A. So dy dx is a gradient. Then given from the question, the gradient is 3. So dy dx equals to 3. Okay, so therefore, to find the value of x, we have to differentiate this one. Differentiate the equation y equals to 2x squared minus 5x plus 3. Okay, we differentiate dy, differentiate y in terms of x. Okay, so you bring down the power, 2 times 2, 4. Then power we have to minus 1. So 2 minus 1 is 1, so 4x. Okay, this one also is the same. We bring down the power, so negative 5 times 1, negative 5. Then minus 1. 1 minus 1 is 0, so x power 0 is just 1. Okay, for this one, 3, this is a constant. So when we differentiate a constant, it will become 0. Okay, so this is the answer for dy dx, 4x minus 5. Okay, then you just compare. So 4x minus 5 equals to 3. So 4x equals to 8. X equals to 2. So this is the coordinate, x coordinate of point A. To find the y coordinate of point A, we just need to substitute x equals to 2 back to this equation. So when x equals to 2, therefore y will equals to 2, x is 2 square minus 5 times 2 plus 3. 2 square is 4, 4 times 2, 8, 8 minus 10 plus 3. We'll have 1. Okay, so the coordinates of A is 2, 1. Number 2. Given that y equals to 4 over x squared and x changes from 2 units to 2 plus m units, estimate the small changes in y in terms of m. So for this question, we are going to find small changes in y, which is delta y. So we are using this formula. Dy dx is approximately equal to delta y delta x. Okay, delta here means small changes. Small changes. Okay, so from this equation, if you want to find delta y, so delta y will approximate to dy dx times delta x. Okay, so we are going to use this equation for this question. From the question, we are given y equals to 4 over x squared. Okay, we rearrange this equation. Y equals to 4x power negative 2. So dy dx will equals to, okay, we bring down the power. 4 times negative 2, negative x. Then the power minus 1, so negative 3. So this is equals to negative 8 over x power 3. Okay, so what's the value for dy dx? We have to substitute the value of x. So from the equation, x is 2. So when x equals to 2, dy dx equals to negative 8 over 2 cubed. So 2 cubed is 8, 8 over 8, 1, so negative 1. dy dx equals to negative 1. Okay, then we have to find the value of delta x, small changes in x. Okay, so x changes from 2 to 2 plus m. So the changes in m is 2 plus m minus 2, which is m. So delta y approximately equal, so now I just write equal here. Delta y equals to dy dx is negative 1 times delta x is m. So the answer is negative m. Number 3. Find dy dx for this equation by using first principle. Okay, so we have to use first principle. The formula for first principle that we learned in class is f prime x equals to limit delta x to 0, then function of x plus delta x minus fx divided by delta x. Okay, we have to use this equation. Okay, this is the equation for first principle. Okay, so first we let y equals to fx. Therefore, we will have fx equals to 2x squared minus x plus 1. Okay, so we already have fx. Okay, then how about fx plus delta x? So fx plus delta x. So we just substitute x with x plus delta x. So 2x plus delta x square minus x plus delta x plus 1. Okay, remember to write a bracket here, to put a bracket here. If not, then your answer will be wrong. Okay, then we expand this. So you will have 2x squared plus 2x delta x plus delta x squared minus x minus delta x plus 1. Okay, so the equation will be 2x squared plus 4x delta x plus 2 delta x squared minus x minus delta x plus 1. This formula. So f prime x equals to limit delta x to 0. Fx plus delta x is this. So just copy down. 2x squared plus 4x delta x plus 2 delta x squared minus x minus delta x plus 1. And minus fx. Fx is this one. So minus 2x squared minus negative x. So you have positive x minus 1 over delta x. Okay, we have to simplify this whole thing. Then you will have limit delta x to 0. So 2x squared minus 2x squared. Then you can cancel out negative x plus x. And also plus 1 minus 1. Okay, so now we left with 4x delta x plus 2 delta x squared minus delta x, okay, over delta x. Then we divided by delta x. Divided by delta x, delta x, delta x. So limit delta x to 0. Then 4x plus 2 delta x minus 1. Okay, limit delta x to 0 means when delta x approaching to 0. So we just substitute delta x with 0. Okay, substitute delta x with 0. So the final answer is 4x. 0 times 2, you have 0. So 4x minus 1. Number 4. The formula is used to calculate the result of 10 from an experiment. The value of k is read as 2.04, but the actual value of k is 2. We are given delta k, changes in k, which is 2.04 minus 2, 0.04. Differentiate m in terms of k approximately equals to delta m, delta k. And we are asked to find this delta m. Okay, so for dm dk, we can obtain it from this equation. M equals to 4 over 3 minus k squared. Okay, so we rewrite the equation. So m equals to 4, 3 minus k squared power negative 1. Okay, to differentiate it, dm dk equals to, okay, we bring down the power. So 4 times negative 1 is negative 4. 3 minus k squared. Then we have to minus 1 again. So minus 1, minus 1, minus 2. Then we differentiate the bracket. So differentiate k in the bracket. So you will have negative 2k. Okay, so negative 4 times negative 2k is 8k. So this negative we write it as fraction. 3 minus k square square. Okay, so this is the value of dm dk. Then what's the value of dm dk when k equals to 2? So when k equals to 2, dm dk will equals to 8 times 2 over 3 minus 2 square square. Okay, the answer will be 16. Okay, then we have delta k, we have dm dk. We just need to put back to this formula. Okay, therefore dm dk is 16. 16 equals to delta m over delta k, 0.04. So delta m equals to 16 times 0.04, 0.64. Number 5, given a triangle, find the area of the triangle in terms of h. Okay, so for part A, this is actually from chapter solution of triangles, but I want to show you how to do part B. So I also put in this question in chapter 9. Okay, so we start from A. So we have a triangle EFG. G. EF is 3H. EG is 8H. And angle FEG is 30 degrees. Okay, do you still remember the formula for us to find the area of triangle? Okay, so this will be half AB sine C. Okay, so let's say this is A, B, C. Okay, this is for the vertices. So the side opposite to this vertices C is small letter C. And this is small letter B. And this is small letter A. Okay, so we can use this formula. So the area of this EFG equals to half A 8H, B 3H, sine 30 degree. Sine 30 degree is 1 over 2. 1 over 2 times 1 over 2, so we have 1 over 4. 8 times 3, 24H squared. So you will have 6H squared. This is for part A. Okay, for part B, the rate of change of area in terms of H. The rate of change of area means dA dt. Let's say the area is capital letter A. Then the rate of change means over dt. Okay, differentiate in terms of t, time. Then we also given the rate of change of H is 0.75. So dH dt equals to 0.75. For this question, we are going to use chain rule, which is dA dt is equals to dA dH times dH dt. Okay, because this dH can cancel each other, then we left with dA dt. So these two are equivalent. So how can we know that? We have to differentiate A in terms of H. Okay, because we are given H, dH in the question. So we know there's something related to H. So we put down dH here. So this is a triangle. And the area, we have found it in part A, which is 6H squared. So differentiate A in terms of H. Then we will have, bring down the power. 6 times 2, 12. H, power minus 1. So 1. dA dH equals to 12H. And also, we are given dH dt equals to 0.75. Therefore, dA dt equals to dA dH is 12H. Multiply with dH dt, 0.75. So the answer will be 9H. Number 6. So given fx and find the first derivative of fx. So first derivative means f prime x. So we are given fx equals to x cubed minus 7 over 2x plus 1. Okay, to differentiate this function, we have to use quotient rule. Because they x for both numerator and denominator. So we have to let u equals to x cubed minus 7. Let v equals to 2x plus 1. So differentiate u in terms of x. We bring down the power of x, so 3x, then power minus 1 squared. When there's a constant, it's 0. Differentiate it, it becomes 0. And then for this dv dx, we will have 2. Formula for quotient rule is v du dx minus u dv dx over v squared. Okay, so we apply to here. Therefore, f prime x equals to v du dx. So v multiplied with du dx. Then you will have 6x cubed plus 3x squared minus u dv dx. U dv dx. 2x cubed plus 14 over v squared. 2x plus 1 squared. X cubed minus 2x cubed. 4x cubed plus 3x squared plus 14 over 2x plus 1 squared. So this is the final answer. Number 7. A conical container of radius 8 cm and height 16 cm is filled with water. Okay, so we have a cone with radius 8 cm and height 16 cm filled with water. Okay, so we are filling water into the cone. So there are some water in the cones. At the same time, water seems to leak away from the vertex of the cone. So while we are filling the water in, the water also leaking from the cone. If the level of water decreases from 4 cm to 3.9 cm. Okay, so let's say this is the height of the water level, h. So at first, h is equal to 4 cm, but because this is leaking, so it decreases to 3.9. So delta h equals to 3.9 minus 4, which is negative 0.1. Find the approximate change in volume of the water in the cone. So we are going to find delta V. Okay, for this question, we are using delta V over delta H is approximately equals to dV dH. So delta V is equals to dV dH multiplied with delta H. So we already have delta H, then we have to find dV dH. Okay, so the formula for the volume of a cone is V equals to 1 over 3 pi R square H. So water level here is keeping changing. So we do not know what is the value of R and H, but we have to find the relation between R and H. Therefore, we have to use similar triangle. So this triangle and this triangle are similar. So let's say this is the radius R. We use the concept of similar triangle. Therefore, 8 over R equals to 16 over H. So R equals to 8 over 16 H. So R equals to 1 over 2 H. Okay, we substitute this back to this equation. Then we will have V equals to 1 over 3 pi. R is 1 over 2 H square H. Okay, 1 over 2 square is 1 over 4. 1 over 4 times 1 over 3. So we have 1 over 12 pi H cubed. Therefore, dV dH. Differentiate V in terms of H. So over 12 times 3. So 1 over 4 pi H power minus 1. So square. Then when H equals to 4, we will have dV dH equals to 1 over 4 pi 4 square. Then we will have 4 pi. Okay, so now we have dV dH and also delta H. We can find the value of delta V. So delta V is approximately equals to dV dH times delta H, which is 4 pi times delta H is negative 0.1. Negative 0.1. So the answer is negative 0.4 pi. Number 8. A spherical balloon expands at the rate of 90 pi cm cubed per second. So this is dV dt equals to 90 pi. Okay. Why do we know this is dV dt, not dA dt or ds dt? We can identify it by the units here, because the unit here is cm cubed. So this is volume, okay, per second, so dt. While its radius increases at a rate of 2.5 cm per second. So this is dr dt equals to 2.5. R equals to K. So find the value of K. Okay, so we are given the formula V equals to 4 over 3 pi R cubed. Okay, we can differentiate it dV dr equals to, okay, bring down the power of R. So 4 over 3 times 3 and 4 pi R squared. When R equals to K, dV dr will equals to 4 pi K squared. Then by using these two formula and also chain rule, dV dt equals to dV dr times dr dt. dV dt equals to 90 pi. So 90 pi equals to dV dr is 4 pi K squared times dr dt is 2.5. 90 pi equals to 4 pi K squared times 2.5, which is 10 pi K squared. Okay, divided by pi. So K squared equals to 90 divided by 10, 9. So K equals to square root 9, positive, negative, square root 9. equals to positive or negative 3. Because k is a radius, so negative 3 is rejected. So the answer will be k equals to positive 3. Number 9. Gas is released from a spherical balloon with a constant rate 0.3 into cm cube per second. Okay, so from the unit here, we will know that this is dV dt, because the unit given is cm cube. Now for this is a volume. Okay, so equals to, okay, gas is released from a balloon. Okay, so balloon, the gas is released from the balloon. Now for the volume of the balloon is decreasing, so we have to put negative 0.32. Find the rate of change of the radius of the balloon in terms of pi when the radius is 10 cm. So we have to find dr dt. Given r equals to 10 cm. Okay. This question will also use chain rule. dv dt equals to dv dr times dr dt. Okay, why do we know that this is dv over dr? Because we are asked to find dr dt, so we know there's something related to dr, so we put dr here. dv dt is given negative 0.32, so we have to find dv dr. So we are also given the formula of the balloon. V equals to 4 over 3 pi r cube. So we differentiate v in terms of r. Okay, we bring down the power of r. 4 over 3 times 3 is 4 pi r power minus 1 squared. When r equals to 10, dv dr will equals to 4 pi 10 squared. Then we have 400 pi. We have 5 dv dr and also dv dt is given. So now we are going to find dr dt. So dv dt is negative 0.32 equals to dv dr 400 pi times dr dt. Now for dr dt equals to negative 0.32 divided by 400 pi. The answer is negative 1 over 1250 pi. Number 10. Find the gradient of the tangent to the curve at point 2, 3. We are given the curve, and the equation of the curve is y equals to 2 over x plus 4x. And this curve passing through a point 2, 3. At this point, we will have a tangent line. Then we are asked to find the gradient of this tangent, which is also dy dx. First, we differentiate this equation. Y equals to, we write it as index form. So 2x power negative 1 plus 4x. So dy dx equals to, bring down the power of x. 2 times negative 1, negative 2x power minus 1. So negative 2 plus, okay, bring down the power of x. 4 times 1, 4. Power of x minus 1. 1 minus 1 is 0. X power 0 is 1. So this is dy dx. And we have to substitute x equals to 2. So when x equals to 2, dy dx equals to negative 2 power negative 2 plus 4. So 2 power negative 2. This is negative 2 over 2 squared plus 4. So 2 squared is 4, 2 over 4, so we will have 1 over 2 plus 4. So the answer is 7 over 4. 11. A cylindrical container with radius of p cm is being filled out with water. So we have a cylinder container with a radius of p cm at the rate of pi over p. Okay, so we are filling up water into this cylinder. From this unit cm cube per second, we know that this is dV dt equals to pi over p. Find the rate of change in terms of p in cm per second of the water level. Okay, water level here. Okay, we are going to find the height. So we are asked to find dH dt. By using chain rule, dV dt equals to dV dH times dH dt. Because we are asked to find dH dt, so we know there's something related to dH. So we write dH here. dH can be cancelled out, then left with dV dt. So these two are equivalent. We have to find dV dH. So the formula of a cylinder is V equals to pi r squared h. For a cylinder, the radius is constant. Okay, always p cm. So we can substitute r equals to p to this equation. Then you will have pi p square h. So dVdh. Differentiate v in terms of h. We bring down the power of h, multiply. So pi times 1, pi p square. Then the power of h, we minus 1. 1 minus 1, 0. H power 0 is 1. So the answer is pi p square. Now we have dv dt and dv dh. We can find dh dt. So dv dt is pi over p equals to dv dh pi p square times dh dt. dh dt equals to pi over p divided by pi p square. So you will have pi over p times 1 over pi p square. Pi simplify, so the answer is 1 over p cubed. 12. Diagram shows an empty cylindrical container with a radius of 3 cm is filled with water. So we have a cylinder with radius of 3 cm. The water rises to 8 cm in 4 seconds. So 8 cm in 4 seconds. That means in 1 second, the height of the water level rises 2 cm. So this is dH dt equals to 2 cm per second. The height of water level increases 2 cm per second. After 54 seconds, all the amount of water in the cylinder container is poured into a cubical container as shown in the diagram. Find the minimum length of the cubical container that can fill all the amount of water from the cylindrical container. So we are given a cubical container. Cubical container means the length of this cube are the same. So let's say this is x, x, x. So the volume of this cubical container will be x cubed. We are asked to find the length of the cubical container. We are asked to find the length of x. After 54 seconds, what is the height of the water level? So we are given dH dt equals to 2 cm per second. So after 54 seconds, the height of the water level will be 2 times 54. Okay, because the height of the water rises 2 cm per second. So after 54 seconds, you just 54 times 2. Then you will have 108 cm. So this is the height of the water level. Because we have to pour this volume of water into this cube. So the volume of the water here are the same. We have to find the volume of water in this cylindrical container. So the volume of a cylinder is V equals to pi r square h. Pi r is given, which is 3. H is 108. From here, you will get 972 pi. So this amount of water is being filled into this cubical container. So the volume of water here are the same. You just compare. So 972 pi will equals to this x cubed. So x must be cube root of 972 pi, which is 14.51 cm. This is the minimum length of x, so that this amount of volume of water can be filled into this cubical container.